So, this is more of a crazy idea I have for a totally radical new ensign for outer space and some other space travel things. But firstly, why do we need economical space travel? Well, there's actually a bunch of huge reasons why this is a very, very important thing. First reason is that when we're traveling, outer space is how we get good weather forecasts that directly benefits mankind. Another one, and that good weather forecast helps prevent disasters, helps plan better shipping and stuff. It also, besides better shipping, it helps plan crops to grow more efficiently and better with less waste, and so much more. Another benefit better space travel is better communication satellites and stuff for internet and everything, and more efficient ones with less environmental impact. Another one is basic science gets promoted. The ultrasound was developed for space-age technology. A lot of the solar cell technology was based on space-age technology. New materials for refractory materials that we're using to protect stuff from high temperatures, designed for space-age stuff. Now we use on everything now from planes to machines and foundries. Better motors, electric motors were designed for space ones. We also can we can grow better crystals, which we might be able to make really expensive pharmaceuticals better, which is a huge opening, and better purify them and extract them from complex things because you don't have gravity disrupting it as much. Now, you might be like, oh, this is very expensive going back and forth, and yes, but we only need a tiny bit for a lot of medication, so it becomes worth it. We can also study basic biology in a different environment to extract factors so we can understand the human body better. We can, for example, we can understand, if we compare to Earth's gravity, we can understand how bones and stuff are grown, but bones growth actually affects calcium emitters and stuff that are pulling nerve cells and thinking. So he could learn maybe more about the nervous system or immune system, because it also affects the immune system, calcium distribution, and might relate to some disorders. Also, it's easier to 3D print biological organs and stuff, maybe for studying or research purposes, but also maybe for organs, because without gravity, to mess up the support systems and make it less easy to delicately place. Other things is that you can use, if you have satellites, you can actually map gravity distribution along the whole Earth to make it, to understand better what's in the core of Earth and seismic stuff and Earth's floor geography, which could help advance ideas about volcano detection or earthquakes and stuff like that. You can make also very sensitive measurements of how stuff is moving, which might lead to better earthquake detection and stuff like that. You can measure forest health and health of whole entire ecosystems. Another huge use right there. We could also try to understand Earth's atmosphere, besides just making weather reports in the moment, to update better weather reports. We can understand our whole solar system better. So the uses, it also can be easier to super cool stuff in outer space, or in the converse, superheat stuff in outer space for cryogenic experiments to test out new superconductors or better made superconductors, which are hard to make when you have high pressure and when under Earth's gravity. So you could have all those experiments going on. You could make astronomy go a lot better because you don't have Earth's atmosphere. And you could just reignite people's spark and interest and curiosity into a whole bunch of things. So hopefully I convinced you that cheap space exploration is good. And this figures anywhere from saying that every cent to 10 cents you put into space travel, you get dollars back, to tens of dollars back. I don't know how, I always doubt these economic figures, but point is, you do get your monies back. So, how do I propose to make a better propulsion system? Well, first of all, I want to talk about something called the Carnot Cycle. And this is the best efficiency any rocket engine can get. And that is where T8 is the hot temperature and Tc is the cold temperature. The cold temperature, you usually take it as the temperature of the injected fuel. Th is the temperature it reaches after burning. The maximum efficiency is above Th minus Tc divided by Th. It's all divided by Th, which also equals to, if you reduce the fraction to 1 minus separate Tc divided by Th, or 1 minus cold temperature divided by hot temperature. The reason for this equation is actually relatively simple. And by relatively simple, what I mean it's actually is just how would I say it? Is imagine that you have an expanding cylinder, and it has hot gas that expands on one end. Another end remains the same temperature, cold. That hot gas that expands, we'll call it expands to T8. But that cylinder presses back, so the maximum amount of energy you can get out of this whole system is T8 minus Tc. And that's kind of what's happening, because this relies on temperature differences. So the maximum of energy you can get is the energy you put into heating up the system, which is the chemical reaction. But then it's divided by T8, because T8 is the total amount of energy in this system. Now, also what limits it in chemical reactions more so, that we haven't discussed, is that this is not the only thing that's going on. What we also have is not all the energy is going into heat. Some of it's going to produce light, some of it's going to electrical things, some of it's going to rotation of molecules, or heat that doesn't directly go into the expansion you want. So you have a ton of energy losses in that manner. Now, not only do you have those ton of energy losses in that manner, but you have additional energy losses, such as some of the heat doesn't go into pressing the cold stuff or in the right direction. It goes into other places, or it's lost. So the cold stuff heats up before it can be used to extract its energy, so it becomes a higher temperature. Some of the energy goes into moving stuff in the wrong direction. Some of it goes into vibrations and stuff like that. And the more complicated the system you have, the more energy losses that can happen. That doesn't mean a more complicated system is less energy efficient, because you might have more and more stuff to regain the energy in different fancy ways. But it can become less energy, but it still has its maximum. The more complicated system has, the more vibrations it could have, or the energy going the wrong direction, or the more places the heat can go in the wrong direction, or that energy can change to other forms, kind of thing. Now you have other practical losses. The fancier you do it, and the more complicated thing, the more work ends in ways, and the fancier the plumbing. Now, also more things that can sometimes maybe go wrong. Now again, you could build in more fail-safes, but then again you get more heavy. So a fancier engine also could have other things that make it better. Another thing is you have to take energy out of actually pushing the rocket forward to pump fuel. This isn't usually a significant amount of energy, but it does exist. You also can't run the engine at full efficiency, because it can usually blow up the engine because it would get too hot or too much pressure. Then you have to design the engine to work under a certain pressure. Now to explain this whole pressure thing is, the engine gas out of the rocket engine expands outwards. You want it not to expand outwards too much. You want to expand all the way down to push the rocket forward. But you can't have just a tube expanding outwards. You have to have some part of the nozzle actually expanding outwards to direct the flow in a certain direction. Because if you have a tube that doesn't have any change in shape, well, it'll just expand back into the rocket, or expand in all directions equally. So you lose power there. So you have to have some bell shape, sort of, to direct the flow of once. Now, the exact bell shape is really complicated, the shape of it, and we're still debating and changing it up for different types, because the bell shape depends on the air pressure, because the air pressure around the rocket also presses on the air on the fuel one, which actually is one of the major losses of rocket engines, is that a rocket engine designed for low altitudes does not work as efficiently as high altitudes, and a high altitude rocket with very low atmosphere or outspace would actually maybe blow up under our atmospheric conditions because it can't take the pressure. The gas expands too much rapidly or too little, and the pressure waves build up and destroy the engine. And that's actually why we have multi-stage rockets. It's actually because the pressure difference when rocket engines work differently in different altitudes. Otherwise, it would be more efficient to have one single stage rocket with an engine that works the best at every stage, because then you don't have to put in the weight of extra engines, and you wouldn't have to dump out them. So it's kind of a myth about the multi-stage rocket, what people usually say why we have it. So you have that. You have all these pump losses, and you can design actually a more efficient engine than a rocket engine, but those ones are heavier and cannot produce as much power because it's hard to scale up for pumping so much energy through. So they can be more efficient, but they can't produce the raw amount of power or work as well, or they're more likely to fail under some conditions. So that's why you don't have a rocket-powered car will not be as efficient as a gas, as you know, combustion engine. And then you have all these problems and limitations, some of them quite practical. Another reason why we limit it is that not only does the pressure and heat can also really limit how efficiently we run it, and remember, the hotter this engine runs, the more efficient it runs, which you can see from this previous equation, that as T8, if you simplify to 1 minus TC divided by T8, the bigger T8 comes, the less you do minus 1, and the more efficient it becomes. So you have to cool it down to make the engine. Is that a lot of it, the chemicals themselves can't corrode the engine because you have oxygen, or it's very corrosive, especially hot oxygen. You have a lot of other chemicals that could corrode on the other side. And there's all these ways around it, but you lose efficiency because you either add weight or you don't run it at its full potential. So now I want to get into fuel cells. So fuel cells do not rely on the Carnot cycle and can actually extract a lot more of the heat energy, but also the nascent chemical energy, because there's no pushback. It's just a transfer of energy, of chemical energy and electrical energy. And how what a fuel cell works is a fuel cell works by turning one molecule or two molecules on either end are reacting into ions somehow. And then the electron, and remember, ions are stuff that has either a positive or negative charge instead of being a neutral molecule or atom or element. One of these ones gives up an electron somehow, and that electron flows through a wire and goes to other ion that's become positive to the end, and then the chemicals react, kind of like a battery. But we have this selective membrane that only lets ions through. So both sides chemicals have to become an ion. So then that means because they have to become an ion, one of them does have to lose an electron. So the electron is forced kind of to travel to the other side, not through a membrane or something, but through the actual wires, and then you can get electrical power. It's very similar to how a battery works, and there's thousands of different potential versions of this. Now you can hook this up to electric motor to power an electric motor. And this electric motor you can use then to pump stuff or turn stuff. Now, how much more efficient is this compared to a combustion engine? Well, if you just do a quick little Google search, it is, compared to a combustion engine, which is more efficient than a rocket engine, it's 2 to 3 times more efficient. So it's crazy amount more efficient, this simple hookup. And you produce a ton less heat. You produce nearly, based on how much more efficient it is, you can calculate about how much less extra heat it produces, and you get about half to 1/3 the amount of extra heat. meaning that if you inject this out the end, your fuel that you're injecting is so much less hot. It's going to be 2 to 3 times cooler, and it's going to be more directed down, so it's less outwards pressure going down because more of it's directed down, meaning that your material, your end nozzle, has to be less strong, less temperature resistant, and it's because it's running under less extreme conditions. You have to think about less compromises, so the engineering becomes simpler and everything, and you can figure out the materials you need better because you don't have to do as complicated calculations. You can also test out the materials better and more normal conditions. You can also, because it's not about thermal expansion as much and all this thermal mechanics, you don't have to worry as much, and it's more directed. You don't have to worry about atmospheric pressure changes causing you to lose efficiency as much. So you can have the engine be more efficient over a wide range of pressures, maybe even all pressures that will go from land to earth, meaning you can save on having less engines, increase your efficiency on the whole drive, saving weight. And remember also, there's even more weight saving because when you have a more efficient engine, you need less fuel, which means you need to carry less weight, and it's a positive feedback loop. But let's say you cannot pump enough things with a fuel cell and the pumps are not powerful enough. I think you could build big enough powerful pumps if you really worked on it. There is still a problem with electric motors getting more and more weight the faster you bring it up. Now, if you use electric motors that uses multiple magnetic coils or Lorentz force or electrical repulsion with newer, lighter weight materials that are more conductive. So using new materials, like I was saying, that are more electrically conductive can eliminate a lot of the weight and increase efficiency even more. So there's carbon nanotube, copper composites, and they're also better at getting rid of heat and stronger so they can withstand stuff. So I think there's a lot of potential there. Also, better transformers could increase efficiency, which is a way of converting high voltage to low voltage that uses DC current. But let's say you still can't fully get this efficiency. Well, we still have a broad range of ways we could maybe do this. Well, also remember, we don't need to make it as powerful as fast if it's more efficient because we need to carry less weight. The other way is that we could make a hybrid motor that uses this technology plus other technology. And we can make even the rocket engine itself more efficient, because what we could do with the rocket engine is pump out the cold water out of the sides, and the cold water or something, the cool product made from the fuel cells, could cool down the rocket engine sidewalls and allow it to be hot in the internal combustion chamber. Which then again, there is a problem with big thermal differences with rocket engines, which we lose a lot of efficiency because that can cause cracking and stuff, which makes it harder to design, which is another pro of this design. If you could get it fully, is that there won't be as much of a thermal difference. But another way is that we could turn it into a new type of ion thrust engine. And what I'm saying about previous ion thrust engines is that they will work 2 to 3 times more efficient than, and these are the ones that exist out there, than a chemical engine. How they work is they take an ion. Oh yeah, I have one other idea. They take an ion and they accelerate it to something, a plate with opposite charge. The impact then hits that plate, but still has movement for moving it, then accelerates past it. If we take this, we can build this into the fuel cell so it actually pumps out fuel rather than a propeller. And this will be more efficient than a propeller by tens of percents. But there will also be less wiring and more simple ones, so maybe even more efficient. And you don't need to have the electrical motor, so you reduce a lot of weight there. You could also design better pumps because we have we're actually designing better pumps that feel more percent efficient than normal pumps with a propeller and rotor design, or piston pumps with few more percent efficient, or fans and stuff in lighter weight that uses actually fishtail mechanics, like a fishtail to pump water instead of a spinning blade, are more efficient. So we have all these other options. I'm getting at. And the reason why a long fishtail thing could be more efficient with pumping water, the long, complicated explanation, is that there's less vortices and stuff, and there's less differential in speed and stuff. So you get more of an even flow and less turbulence that might be sucking away energy. You can pack stuff tighter together. But if that doesn't work enough for the flow, what I think that could do, and might be the thing we want to do from the beginning, is you use some of this electrical energy to ionize the gas with something like a Vasmeer ends and stuff by sending radio waves. That ion then hits a screen and becomes even more ionized because it gives electrons or a solid one. Then it hits into this then ion, the electrons then travel in a larger, more powerful one into ionizing the other chemical with the opposite charge, which is then pumped into a rocket chamber, and the whole thing is forced forward. This way you can have a fuel cell-like device that works at much, much higher temperature by making a lot of the extra stuff external, basically. So I really think that that idea would work, and work very, very well, in fact. Not only, so, yeah. The other one we could, and it would take a lot of re-engineering, radical one, but I think it's something very much doable. Other advantages of the system that I haven't gone to yet is that if it's all based on electrical energy, speeding up stuff, once you're in outer space, you can use the sun to power this and make it even more powerful than the fuel you carried above. So whoopee whoop, you can get solar power energy boost. So we have that going for us. Another one is that if you use it to power, you could use it to power the spacecraft during emergency, like a battery system, or to store energy for a spacecraft. So you can have it as a built-in battery system. Another one is this is better works with hydrogen, which is a very finicky, hard to use fuel, so we don't use it often. Instead, people are slowly going more and more to methane. We were using more like a gasoline fuel oftentimes, called RP1, but it's rocket propellant 1 is the most common one, and RP1 is a very specialized form of gasoline. But RP1 has a lot of it's not as fuel dense, but it's easy to pump and handle than methane or hydrogen, which is hard to store. Methane is harder to store than RP1, but a lot easier than hydrogen, which can escape through the most microcracks possible. But it's also a lot easier to pump at high rates, so the pumping equipment becomes a lot more simple and better handle. The advantage with this one with hydrogen that makes hydrogen more of an accessible fuel is it burns at less hot temperature, so you have to worry less about corrosion with hydrogen and stuff, and oxygen corrosion. It also, and less high pressure. Also, that you need less fuel, so leakage doesn't matter as much. So, especially if you're talking about for short durations. So you have all those advantages. Well, I think this is, oh yeah, and also if you're using hydrogen and oxygen, which is at lower temperature, you can make water for your spacecraft too. So you could have this whole thing being a better water generation device while you're making power. Or you can run in reverse and turn water into hydrogen and oxygen more readily if you have a built-in fuel cell system. And that built-in oxygen can be used for helping you breathe, while the hydrogen can be used to make chemicals, even maybe food, in some weird mixture of or bio and artificial technology. And hydrogen also has the advantage that if you have a lot of hydrogen, just hydrogen itself, it's one of the best radiation blockers for outer space radiation. So yeah, and if this spacecraft gets more power from solar cells, you might as well install more solar cells on your spacecraft, now I think about it, which means that because there's less of a disadvantage of storing more solar cells because you get the power back once you're in space, which means you can also just have more, when you're not moving a spacecraft, you have more power for all sorts of experiments, so it's not as much of a trade-off between having powerful experiments and having powerful spacecraft. Or you can do more places go more weird orbits when we possibly blocked out by the sun. And more solar panels can also be used to block out sealed part of the spacecraft from the sun, better making the spacecraft better temperature controlled and from radiation from the sun. So a ton of benefits to the system. Well, thank you very much for listening. Please like and subscribe. It will help us to 10 out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but you help I think can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave in the comments section below. Again, thank you very much. Goodbye.